Assalamualaikum and hi guys. My name is Muhammad Izwan bin Ishak. My number metric is 09DEP20F1082 and I from class DEP2C. Today, I will present end of chapter for my subject semiconductor and my topic is the basic principle of MOSFET, physical structure and schematic symbol for both MOSFET, NMOS and PMOS. Okay, first, we go to the basic principle of MOSFET, NMOS and PMOS. As well as the junction field effect transistor, JFET, there is another type of field effect transistor available whose gate input is electrically insulated from the main current carrying channel and is therefore called an insulated gate field effect transistor. The most common type of insulated gate FET, which is used in many different types of electronic circuit, is called the metal oxide semiconductor field effect transistor, or MOSFET for short. The IGFET or MOSFET is a voltage control field effect transistor that differs from a JFET in that it has a metal oxide gate electrode which is electrically insulated from the main semiconductor N channel or P channel by a very thin layer of insulating material, usually silicon dioxide, commonly known as glass. This ultra thin insulated metal gate electrode can be thought of as one plate of a capacitor. The isolation of the controlling gate make the input resistance of the MOSFET extremely high, way up in the mega ohm region, thereby making it almost infinite. As the gate terminal is electrically isolated from the main current carrying channel between the drain and source, no current flow into the gate. And just like the JFET, the MOSFET also acts like a voltage control resistor, where the current flowing through the main channel between drain and source is proportional to the input voltage. Also, like the JFET, the MOSFET is very high input resistance, can easily accumulate large amounts of static charge, resulting in the MOSFET becoming easily damaged unless carefully handled or protected. Like the previous JFET, MOSFETs are three terminal devices with a gate, drain, and source, and both P channel NMOS and N channel PMOS MOSFET are available. Okay, we continue to the next slide. There are two types of MOSFET. What is it? It is depletion enhancement MOSFET, or the other name, the MOSFET. The transistor requires the gate source voltage VGS to switch the device off. The depletion mode MOSFET is equivalent to a normally closed switch. And the second MOSFET, it is enhancement MOSFET, or in the other name, eMOSFET. The transistor requires a gate source voltage VGS to switch the device on. The enhancement mode MOSFET is equivalent to a normally open switch. Okay, we go to the next slide, guys. Okay guys, for this slide, I will explain about depletion enhancement MOSFET, or the MOSFET. Depletion enhancement MOSFET, or the MOSFET, can operate in two modes. It is depletion and enhancement mode. This can be done by changing the voltage polarity between the gate and source VGS. When the VGS is negative, the MOSFET operates in the depletion mode. Conversely, when the VGS is positive, it operates in the enhancement mode. Figure 6.8 and 6.9 show the symbol and structure of the MOSFET. We can see that the channel is connected from the drain and the source, so the drain current can flow even though VGS equal to 0 volt. Like you guys all can see, A is in figure 6.8, there is structure for N channel the MOSFET, and beside it is the symbol. And for figure 6.9, there is that is structure, P channel for the structure, P channel, the MOSFET, and beside it is the symbol. Okay guys, you with me again? For this slide, I will explain about the other MOSFET, that is enchantment MOSFET. Enchantment MOSFET or MOSFET operates only in enchantment mode with less positive voltage supplied at the gate G terminal. The structure and symbol for MOSFET are shown in figure 6.12 and 6.13. Based on the structure of MOSFET, there is no channel connected between the source S and drain D. This causes no drain current ID to flow when VGS equal to 0. ID flows only when VGS exceeds VGST, gate to source threshold voltage. As you guys all can see, that is the in figure 6.12, that is the structure for N-channel MOSFET, and beside it is the symbol. And in below that, in figure 6.13, that is structure for P-channel MOSFET, and the symbol is beside it. Okay, we go to the next slide. Okay, we have reached the last slide. Thank you very much for your great attention. To all my friend, my lecturer, and all my viewers, thank you for your attention. Again, thank you for listening. Thank you for being with me from the first slide to the last slide. May all those we have shared be beneficial for all of us. The last, my name is Izwan, and don't forget to subscribe my YouTube channel for look at me. Thank you. See you soon.